Today, we're going to play with Basil.
Basil, are we making pesto today? But we cannot use macaroni. We need trophy.
No, I'm talking about Basil, the build and testing tool. Pesto can wait.
Okay, you have my attention, but now I'm hungry.
Okay, go grab a snack and let's start from the beginning. Okay, before starting, a small disclaimer. Basil is an open source project developed by Google. I'm currently a software engineer at Google, but this video, as all the others on the channel, is not sponsored by the company, is not connected with the work that I do there. Any comment or opinion is our own and not related to our respective employers. And well, with that out of the way, let's actually start.
Yeah, show me something.
Okay, so every Bazel project starts with the same file, which is module.bazel. For now, we leave it empty. This is where we are going to put some dependency later.
Okay.
Next file that we will always have is the build file. Again, we leave it empty for now, and then we will use it later.
Okay, so it's like a makefile?
Well, it uses a different language, which is called Starlark, which is a dialect of Python. So it's Python with fewer features, but it's, in my opinion, way more readable and self-explanatory than a Bazel file. Sorry, than a build file.
Show me something.
Okay, let's start with a simple hello world. So we go here, pretty simple, classical. So now, well, we're working in C++ in this case, so we need to include the package, the dependency of the rules CC. This is a package that contains all the build rules related to C++.
Okay.
So we go here in the build file and we finally do something here. So first of all, we go and we load the rule that we need. In this case, the rule is CC binary. And we actually create our build target, which is going to be hello world. To build this, you just go Bazel, build, the column separates the path from the target name, and you say hello world.
Okay, perfect. Oh, and there it is.
You see there are a bunch of additional folders. These are temporary files, build files, and generally your file is here, is in Baseblane, is the same name of your target, but in reality you don't care about it unless you're packaging something, because what you actually do is that you go and you call Bazel run.
Okay.
Yeah, you have noticed that it actually reused the previous build because it understood that the file didn't change, so there was no point in rebuilding.
Okay, it works like a charm. It seems to be.
Yeah.
Okay, but what if you want to build an optimized version, for example, of this build?
Okay, so, well, you can go and add an argument called compilation mode. And, well, you have 3, which is debug, which is a classical debug with all the debugging information. There is fast build, which is the equivalent of O0 in GCC, where we don't have debug, but you are not optimizing. And then you have opt, which is the version that goes. So it went, it rebuilt and run, but for difference, C compilation mode is just -C.
Okay, easily. More easy to use and to remember. Okay, and what if I want to split the project in multiple file or build units?
Okay,
so there is something that we can do?
Yeah, let's go and do it. So let's create a greeting generator. So you will create a greeting.page in which we'll define some basic greeting. So we use the generator's namespace, and we have this generate greeting function. And then we go and we create the greeting.cc, and we put our implementation. So trust me, bro, I generated this randomly.
I trust you.
So we go back, and now we go to the main file. We include our greetings, and we go and call our generator. But well, we need to define our library. So we include a new rule which is called CC library. So binary actually is equivalent of post linkage. So it's an actually executable. Instead, CC library is more equivalent of building an object file, a .o file on Unix. So in this case,
makes sense. More clean. Yeah.
So we go and we add the CC library. We call it greeting. Again, we have our source file. We have our header files. So the source are used during compilation. The headers are the one that are exposed to others. And actually, we need to go and say, hey, my main CC binary depends on this greeting library. So we can go again, maybe we can rebuild. So you see it goes through, rebuilds, and works.
Okay, now you have multiple files. The function, the main functionality of the code is separated. But what if I want to create a more structured project with some subfolder or so on? There is some magic that we can use. There is a way to do that. It's capable of do that.
Yeah. Well, no magic in Bazel. It's all explicitly defined. So you just go, you create your folder.
Perfect.
And well, if you just, as I said before, the build file is always there. So you create your build file, and let's say that we're moving this greeting under here. And so we go and we move part of this definition down there.
Okay, so the library part.
Yeah, we move the library here. We remove the CC now. And it's here, and we need to, at this point, update the dependency because now it's not in greeting, but is in / generators greeting.
Okay, so the / is a sort of root folder of the project?
Exactly. / is the root folder of your project.
Okay, and in the load is the root folder of the rule CC library. So
exactly, yeah. Rules defines the package depending on the dependency of the entire project. / is the root. Then you have a path, and then the column separates the path from the actual target that you're trying to build. In this case, greeting is the target. So we go, try to build a woohoo. Doesn't build.
Are you mocking me?
No,
you did it on purpose?
I did it on purpose because, well, by default, targets are visible only to other targets in the same build file. So the default visibility is build file. So if you want to make, so you don't want to leak your tests or your utilities or your implementation details to the rest of the world, because I mean they are implementation details. You don't want to people accidentally depend on them. So you can go and you can have fine-grained visibility, but in this case we can go with a simple approach, which is, well, this greeting, I want it to be visible, again, / the root of our project, and package is just a shortcut for the entirety of our project. So we go there, we build, and I forgot to update the dependency here.
Oh, man.
Generators / and now it will work. Yeah, so it's working.
Okay, it worked like a charm. So what about the sub-dependencies?
Okay, so we can go and make this.
Yeah,
let's make it a bit more structured, and let's say that this is a greeting generator. We can have a name generator. So instead of the greetings, we generate this one generates names, and so it goes here, and you have your generate name folder. And even if I'm here, let me also fix these ones that they are correct and aligned.
Okay.
Great.
Yeah.
And we go and we add our name.cc implementation.
Perfect.
And again, trust me, Bo, I generated this randomly. And
okay, I trust you. Yeah.
Okay.
Absolutely.
And well, let's also improve a bit this one, and we keep our generate greetings, but we also want to add a generate greeting for, which is a version which
Okay.
takes a name. And so we can now go and say that our implementation changes to the default is generic greeting for and the name, and the default for generic greetings for is hello and a name. So at this point,
Okay. Yeah.
as you know, we need to go and add our CC library. So we have our name, and we can go, and as we did for the main CC binary, we can go and say that these greetings depend on it.
Okay. So in this example, the name library is only visible to greetings, not to all the package.
Well, it's visible to the entire build file. So in this case, well, yes,
Okay.
just to do greetings.
Okay, and it seems to work.
Yeah, it's there, works.
Absolutely, but okay, I trust you that it is random, yeah, but you can make it random for real.
Okay, you don't trust me, bro, huh? Okay, so
no, I trust you, but I'm sure that is not random. I don't know why, but
okay, okay. So let's add an additional dependency to the project, and this is the Upsail library. This is a super cool library that provides advanced functionalities, provides cross C++ version compatibility. We're not going into the details in this video, but it's also a way to say that you can actually include entire libraries as a dependency to your whole project.
Probably we can do a video later for the Upsail.
Potentially. So
yeah, people leave it in the comment if you want.
Yeah, leave it in the comment. So what you can do here is that, okay, let's go into our hello world, and we want a random bit generator. So we go and we include our random library from Upsail, and we just add a bit generator, and we provide it to our greetings. But also we need to go and include this extra dependency. So we need to go and say that we also depend on the random folder inside the Upsail library. Again, as I said before, this is the package, root folder, and the path. In this case, we're including the entire. We are not including. We are depending on the entire random library. So
perfect. So all the targets.
Yeah,
that include.
Let's go deeper, and we are going to now add the functionalities also here. So we include, in this case, we use bitgenref, which is a way of using different bit generators, and we provide it to our generators. And then we go in our implementation, and we say, okay, so we depend on bitgenref, and we include it here, and we provide it down to all our generators. And then finally, to make you happy, I'm going to remove my trust me bro.
Yeah.
And I'm going to instead
giving so random.
Yeah, so I'm going to use a uniform, which is a distribution. So we need to include the uniform, the distributions header, and this one just generates a number between 0 and 4 not included. And so we can go and say, for example, case 0, we generate hello and a name. I'm using Strucat, which actually comes from another Upsail library called Strings, which have utilities that make it easy. And in this case, the case 0 is hello name. And then we can go and add some other cases. And we can say that, okay,
give me more.
One case is welcome name, another case is name, it is my pleasure, and so on and so forth. And my favorite, ciao.
Yes.
Okay, and yeah, and then we go and we do the same thing for the name generator. So we include bitgenref, we provide it too. And then we go and we change the implementation. Again, you don't trust me, bro. So
with a name.
Same thing with 3 random names.
Yeah, absolutely the same. Okay.
And now we need, well, we cannot run it because we haven't included the
Ah,
dependencies. So
oh
I don't
yeah.
want to trick you again. So in the
Thank you.
greetings library, we have included the BJNref distributions and the strings library. So you can go and define it in this way. And in
Okay,
the name library, we used just the BJNref and distributions.
perfect. Yeah,
So
makes sense.
unless I did something wrong, yeah, it works. So Kata, it is my pleasure
Oh,
to meet you.
show me that is real random.
Hello world.
Oh yeah,
Well,
it's real random. Okay.
welcome Berna. So yeah,
Okay,
it's
so
working.
it's real random. Yeah, and now it works. I want to ask you, what can we do next?
Well, what we can do is that, for example, we could add some tests, and there are some,
Okay.
for example, in the in the rules CC, there are the CC test library, and for other languages, there are other libraries where we could go and build our own rules if we want to do something special that is not supported by any other library available, or we could even
Yeah.
go and build code generators and advanced stuff. But hey, do you hear it?
What?
Oh, the water is boiling. Time to go.
Oh, okay. See you next time, folks.